Hello, this is Hands-on Auto DevOps with GitLab CI. This is Section 5, Custom CI Infrastructure. In this section, we'll look at launching dedicated runners, automating runner deployment, auto-scaling runners using cloud resources, custom Kubernetes runners, and a private GitLab server install. Launching dedicated runners. In this video, we'll look at installing GitLab Runner, registering a project runner, and some runner types. So far, all of our GitLab CI pipeline builds have used the shared runners provided on GitLab.com, but there are a few reasons we might choose to run our own dedicated runner. One is that we might need software or configuration that is not available easily in the shared runner. So we might need to install and control and manage software ourselves, and we can do that from a dedicated runner. Another is we might need more runner resources than are available from the shared runners on GitLab.com. And the third is if we need to install our own private GitLab server, then we'll need to also install runners so we have those available on that server to use. Let's take a look at how we can install and register a runner for a project on GitLab.com. We'll start out looking at our basic build repository. If you remember from our previous section, this is the repository that has the simplest possible GitLab ci.yaml file. Let's look at the most recent build. If we go to the job page, you can see that it identifies one of the GitLab.com shared runners as the place where that happened. GitLab.com provides a number of shared runners. They auto-scale as needed in order to run jobs, and that's where this particular job has run. If we want to switch this particular project so it can run on a dedicated runner, we'll need to grab a registration token and use it to register a dedicated runner to this particular project. Let's look at how we can do that. We'll go to Settings, CI/CD, and here you can see a section in the middle for runners. If I expand that, you can see on the right, these are the shared runners that we have available. But you can see that we have a limit of 2,000 minutes per month that are available for us to use. So that's one of those reasons I talked about why we might want a dedicated runner. On the left, you see how we can register a specific or a dedicated runner for our particular project. One of the items, the most important one that we need to grab, is this registration token. So I'll go ahead and copy that to the clipboard. Now that I've done that, let's do the actual install and registration. So I switch over to a console window. Right here, I have an AWS instance that I've created. It's actually running Amazon Linux 2, which is very similar to CentOS or Red Hat Enterprise Linux. So those are the install instructions that I'll be using from GitLab.com. I've already run the script that creates the repository, attaches to the GitLab repository where the runner packages reside. I'll show you exactly what that looks like. If I list out the contents of the etc yum.repos.d directory, you'll see the GitLab runner repo that's been created. So here you see there is a GitLab runner.repo, and that contains a pointer to the location on the internet where we can install the GitLab runner package from. So we can go ahead and do that using the yum command. And in this case, the -y just tells it to go ahead and not prompt me for confirmation. That will just take a moment to download and install that package. And once it's finished, I have that runner service installed and ready to go. There's just one more step that I need, which is to actually register it with my particular project on GitLab.com. That token serves as something of a passcode to say that it's okay for this particular runner to build that job. Obviously, that's something that could potentially be sensitive and you want to have some security around. So we'll go ahead and register the runner. You'll see that the first thing that it prompts me is where the GitLab server is located. And since we're using the regular GitLab.com one, that's what I'll provide as the URL. Now it's going to prompt me for the token. I'll just paste in the one that we copied to the clipboard. It asks me for a description. I'll just keep the default. And then it offers to let me create tags. Tags are a way that I can identify exactly which job in my GitLab ci.yaml file should build on which runners. I'll just add the tag AWS. So that's now gotten through the registration process. The last thing we need to configure is the runner type. There are a number of different types. For this purpose, I'm going to use the simplest, which is shell. And we have our process complete. We'll go ahead and we will make sure that the service is actually started and running on the box. And so now that that's done, we have our runner up and ready to go. If we jump back over to our browser window and we reload this page, what you'll see as we open that runner section again is that we now have a specific runner that's been activated for this project, and it has that name that we saw on the AWS side. So now this is ready to go. It's ready for us to use. Let's take a look at how we tell it to use this particular runner. We'll jump over to our code window and we'll open the GitLab ci.yaml file. Here's that very simple YAML file I mentioned. We're going to tell it that this build job needs to happen on that specific runner. And I'll do that by using the tag that we created a moment ago. So you can see here that I've added that AWS as a tag for this job, and that indicates that the runner that it runs on needs to have that tag in order for it to run. So if we now jump over to our terminal window, we'll check this code in and we'll let it build, and we'll see that it builds on the new specific runner that we created. So here I have a regular terminal window right here where my code is located. I've committed that change, I'll push it, and that will kick off a build, and we'll come back in just another minute when that build is complete. So now you can see the output for the job that we just had it run. You can see that rather than using one of those shared runners, it's using the shell executor on the particular runner that we created in AWS. And of course, in this case, because this is such a basic script, the result is still the same and it still builds successfully. So that's how we were able to dedicate a runner to this particular project and then configure this project to use that runner in order to run our build. That was the shell executor. There are a few other types. You saw a longer list of them, but these are the most important ones. That shell runner that we saw, it runs the builds directly on the runner host. And what's nice about that is if that's a physical machine, it makes it very easy to build virtual machines. It also makes it easy to build Docker images from that particular machine. The type of runner that we saw with GitLab CI was auto-scaling, but it was auto-scaling based on the Docker type. And that runs all of the builds in Docker containers. So when we built a Docker image in that environment, we had to use that Docker in Docker configuration we looked at in the previous section. There's also the Docker machine type. That's the kind we'll look at later in this section for auto-scaling. What it does is it launches new virtual machines, and in those virtual machines, it runs builds in Docker containers. And then finally, later in this section, we'll also look at the Kubernetes type that actually runs our builds inside Docker containers, but it does it using the Kubernetes cluster. What's nice about that is if we already have a Kubernetes cluster to deploy our application to, we can use the same Kubernetes cluster to run our builds.